Welcome. In this video I'm going to show you how you can perform a paired samples t-test in Microsoft Excel. This is using a alternative method than in another video where I will be needing actually an additional column, but I actually prefer this method. It's slightly less complex. Another method where you don't need this additional column is explained in another video, and there will be another video with showing a third method where I'll actually be using the data analysis toolkit, but I actually prefer this method as how I would personally do it. It starts off the same as in the first method where we need to remove any pairs. This is my original data, but for example here I don't have the data input here, so this one should actually be ignored. We can do that by simply using an if function equals if this one is nothing, um, or if this one equals nothing or the other one equals nothing. In those cases it shouldn't do anything, and otherwise it should return the before. Now I close the parentheses and I actually want a dollar sign in front of this A. You can press F4 a few times on the keyboard once you're in the cell or the cell reference, and the dollar sign should be in front of the A and here in front of the B. Press enter or control enter, and then you can copy it to the side, and then you can copy paste it all the way down. Now what this does is it shows the exact same values, but now it removes both values in case any of them is missing. So for example here there's one missing, so it doesn't get in, and also this 48 is not showing up here anymore. Then we need to determine the difference for each pair, and so that's simply the before value minus the after value. And then you can copy paste this down or double click on the autofill handle. We might actually want to put an if in front of it in case it's missing. So if this one is missing, then nothing, otherwise do this. And now if I copy paste down, these two errors will disappear. Step 3 is then to determine the average of all of those. So average of column E, assuming that you haven't typed in any numbers above or below. Otherwise you need to specify the exact range. The number of pairs, that actually goes for all of the times I select an entire column. The number of pairs is actually simply the count of either column C or D, in this case 24. Then the standard deviation is the standard deviation of the differences, so you can use standard def, that's the old one, or .s for the new one, and of column E. And then we have a few divisions to be done. The standard error in itself is the standard deviation of the difference divided by the square root of the number of items. That's this scary looking formula up here. The t-value is then simply the difference that we calculated divided by the standard error, and the degrees of freedom is simply the number of items minus 1. And then we can determine the p-value or the significance. You can use the old t-dist, so equals t-dist, and then take the absolute value of the t-value and close that semicolon, the degrees of freedom, and then we want it two-tailed, close, and that should give us the p-value, in this case 0.025 around it. You can also use the newer t.dist, and then let's go immediately for two-tailed, and then you only need to specify the x value. Again, first the absolute value, and then specify the degrees of freedom. Since you already indicate here with the 2.2t, you don't have to indicate that it's two-tailed because that's what this 2t does. And of course it gives the same result. Now this is below 0.05, so most people would consider that significant. So we could say that there is a significant difference between the before and after results. You might want to calculate those averages then independently to actually see which one is bigger. You can also determine that from the D. In this case the after is actually bigger because it's negative, so that means these numbers on average are smaller than these. And that's how you can perform the test with Excel.